Hello, I'm Norman Swan. Welcome to another edition of Tonic. This week, how iron when you're a child can affect your brain when you're an adult.
Folks with more of this insulation had a higher IQ. And so if you tested them on a standard IQ test, mathematics and language, the people that performed better were also the ones with more of this fatty insulation on the brain cells.
And speaking of iron, how to reduce the need for a blood transfusion after surgery.
What we've recognised is anemia is increasingly common. Their risk of needing a transfusion was 5 times higher than the patients who were not anemic.
And we'll take a look at the latest research into just what is happiness.
Do you trust the police? Do you trust your neighbours? If you dropped a wallet, would your neighbour be likely to return it? Would the police be likely to return it? Even a small change in that likelihood is worth many times your income.
How well our brains develop in childhood and adolescence is critical for the rest of our lives. The better developed your brain, the better you'll do throughout life, and the later your brain will decay. Researchers at the University of California, Los Angeles have teamed up with researchers in Australia to look at the issue of brain development and are finding that an important element in the development of young brains is iron.
One of the big surprises is that the level of iron in these folks' diet was a really good predictor of how intact the brain's wiring was. So you can see on a brain scan whether the brain's basically healthy or whether there's signs of disease. And the amount of iron that these folks were having in their formative years and their teenage years ended up being a good predictor of how healthy their brain looked later in life.
At what age and how strong was the relationship?
Well, it was pretty strong. So we measured the iron levels throughout the teenage years, and then we looked at their brain scans when they were between 20 and 30. And so it basically looked like what was separating the really fast brains, the ones with good coating on the neurons, from the ones that looked less good, was some of the things that they did with their diet.
And was it really iron or something else in their diet?
Well, it's interesting. So we traced it to iron because we measured the level of a protein that routes iron around the body. And so you can have a test of your iron levels. It'll fluctuate from day to day. If you have a steak or you have a bowl of spinach or something like that, your iron levels will fluctuate. So we measured this protein that's a good estimate of the amount of iron you've had over many years. It's called transferrin. And the levels of this was a very, very good predictor of brain integrity later in life. And these were in people that were otherwise healthy. They didn't have a poor diet. They weren't iron deficient, just regular teenagers, like you see every day.
You're talking about the integrity of the brain on a brain scan. But did it actually mean anything in these people's lives?
Oh, it did. And so one of the things you can do with brain scanning is you can measure the level of a substance called myelin. And it gives you an index of how fast your brain is communicating.
This
impulses.
is the insulation around your nerves.
Exactly, the insulation. And it's a fatty substance, but it's helpful. So what we found...
And insulated nerves tend to transmit information faster.
Oh, they do. And so as we all grow up, we get more and more of this insulation in our brain cells. And it makes the difference of about a factor of 100 in terms of how fast the impulses are routed from place to place. So one of the things that we saw in the scans is that the folks with more of this insulation had a higher IQ. And so if you tested them on a standard IQ test, mathematics and language, the people that performed better were also the ones with more of this fatty insulation on their brain cells. And this is something you can see in a standard brain scan.
But studies by your collaborators, in fact, in Brisbane, have shown that intelligence is 70% genetic. So where does this leave this strong environmental influence?
It looks like it's a bit of both. And so it looks like, good genes are going to be helpful in improving your IQ, but also diet's very important as well, and education and good luck. I mean, I think we've often seen that the things that determine your IQ depend from society to society. And in impoverished countries, the thing that'll matter is your diet, and that's the number one thing. In relatively richer, wealthier countries, a lot of it depends on your genetics.
And did they get less multiple sclerosis? Because myelin is this fatty sheath, and the fatty sheath is what gets eroded in multiple sclerosis. So you think that if they've got more of it, they might be more resistant.
There's a very interesting connection there. So one in 10 of us has a gene or a variant of the gene that makes iron more available in the body. And so the iron that you eat in your diet is better able to get into the brain and build this coating. The people that have the bad variant of this gene have a higher incidence of multiple sclerosis, of an illness called ALS, and also of Alzheimer's disease, motor neuron disease, and also of Alzheimer's disease. So I think what we're beginning to see is iron is not just important for development early in life, but it's also very important later on. And some of the genes that control the level of iron in your brain and in your body are critical for later development of these neurological diseases.
But genes also determine how much iron you absorb from your diet. So could genes be influencing this iron story in an indirect way?
In the extreme case where you get 2 copies of this bad variant, you have an iron overload disorder.
This is called hemochromatosis.
Hemochromatosis. And so the only way...
In fact, it's the commonest genetic disorder around, isn't it?
Absolutely. In some countries, it's as high as 1 in 100 people. So people who have that, they can take steps to restrict the iron in the diet, just don't eat things with a lot of iron. And one of the interesting things is if you only have 1 copy of this bad gene, you won't notice anything at all different, you won't have any health problems, but your brain wiring looks a lot better. Now this is a peculiar finding. Why would someone that carries a bad gene have a better looking brain? Well, early in life it's giving you more of this fatty substance in your brain, more myelin. Iron helps you build a better brain, so to speak. The trouble is later in life we can't clear iron from the brain. And so when you're older you have to be much more circumspect about the level of iron that you ingest through diet, because it builds up in the brain and it produces a lot of what's called oxidative stress.
Rusting,
minerals.
if you like.
Rusting of the neurons, I like that, rusting of the neurons. And we found that in people with Alzheimer's, they often have a very, very high iron content in the brain, and it's just because we can't clear it. It builds up and you can't clear it.
This is just an observational study where you've noticed the link between iron and brain development. But does it tell you anything that could advise parents for something practical about how they might deal with their children or adolescents? Because there are risks in too much iron and risks in too little.
For something as subtle as iron levels to make a radical difference on a brain scan, that really does put the focus on getting a decent diet. I mean, whether it's meat or leafy greens or other things that contain iron, it seems to be much more important than we thought.
So if what you found is right, the quality of nutrients in a teenager's life is critical to their future and needs more attention.
Absolutely, and so much so that you can see it on a brain scan. So there was a visible difference in the scans of these folks with a good diet.
Now, if you're tempted to rush out and buy your teenager some iron pills, I've got a few things that you really need to know. First of all, in that study, the kids were eating iron in their normal diet. They weren't taking iron pills. And you can get plenty of iron from your diet, from lean red meat to leafy green vegetables and other foodstuffs. And just remember, when you take iron in food, you're getting all sorts of chemicals with it that help the iron to be absorbed and probably used better in the body. And there are potential risks. You can have too much iron when you take it as a supplement, and that can affect your immune system and even your heart. And next week, we'll be coming back to Professor Thompson to hear about his research into brain health and obesity. But one of the biggest uses for iron in the body is in fact carrying oxygen in red blood cells in the blood. And one of the ways to counteract too much blood loss is a blood transfusion. But there are huge issues in terms of maintaining an adequate blood supply for the community. Tonic's Consumer Affairs reporter Karen Carey has been talking to Dr. Simon Towler, who's been concerned about meeting these challenges of an adequate and safe blood supply and how consumers can be part of the solution. And as a declaration here, Karen Carey has sat as a consumer representative on a steering committee of the Australian National Blood Authority.
Blood is precious, and for someone who needs a transfusion, it can be the gift of life. But with increasing worldwide demand and low donor rates, we're struggling to ensure sufficient supply into the future. Some countries are responding to this challenge by paying for blood donations, whilst others are trying to reduce demand for blood products by ensuring that transfusions are only given when absolutely necessary.
What we've discovered is the rate at which transfusion, red cell transfusion, is used in the older population is some 6 times higher than the background average transfusion rate. It's the most rapidly growing sector of our population. And so we believe we face into the future a supply risk if we do not change our practice. It's not that we're trying to stop people using transfusion when it's necessary, but at the same time there are estimates worldwide that something like 30 to 50% of transfusions could be avoided by a more comprehensive, or what is now known as patient blood management approach, where you use alternative treatments. We know that you can largely predict transfusion requirement in the surgical setting. Preoperative anemia, intraoperative blood loss, and the practice of clinicians at what we call the hemoglobin trigger, in other words the level at which they initiate transfusion, predicts 97% of all transfusions in the surgical setting. If you address the needs of the patient in advance, then you can use other forms of treatment like iron infusions or oral iron.
The level of hemoglobin in your blood is used to decide when a transfusion is necessary, and the latest evidence is showing that this trigger point can be safely lowered in a hospital setting where they can monitor your symptoms closely. Overall demand can also be lowered by reducing the amount of blood that's given to each individual patient. An average transfusion uses 2 to 3 units, but the evidence is showing that less may actually be better.
When transfusion's needed, if the patient's not actively bleeding, the evidence suggests 1 unit at a time and reassess the patient. In fact, patient outcomes under these kind of programs are often better.
So wanting to minimise the use of blood transfusions isn't just about supply and demand, because there's risks involved, aren't there?
Absolutely. I mean, it's almost a transplant. This is allogeneic blood. It comes from another patient. Yes, we go through a cross-match process that ensures that there is compatibility between the donor blood and the recipient, but it's still somebody else's blood and the body responds to that. And one of the great things you can say about receiving blood products in Australia, we have a high quality service and the risk of getting an infection from blood is surprisingly low. What has been forgotten are the other adverse effects. So what we know is the commonest things are still temperature or febrile reactions, which then lead to the transfusion being stopped, often relatively benign, but things like volume overload, in other words, too much volume in the patient, or a reaction called transfusion-related acute lung injury, which is an inflammatory condition in the lung, are now more commonly identified. But lurking in the background is still the problem of people getting a bacterial infection, particularly from platelet concentrates. What all this says is if you can avoid it, all the better.
So if someone's planning to have surgery, is there anything they can do to reduce the likelihood that they'll need a transfusion?
Anemia is increasingly common in our older population. If you manage anemia before surgery, you